Okay, factoring quadratic equations. So if I asked you to factor just a normal number, what I want you to do is find numbers that multiply to make that number. So in this case I've listed some factors of 30. So 1 times 30 makes 30, 2 times 15 is 30, and 3 times 10 is 30. These are all factors of 30 because when you multiply them together you get 30. So factoring quadratic equations is the same principle. Here we have a quadratic equation, and if I ask you to factor that, what I want you to do is find two linear expressions that multiply together to make that quadratic equation. So if I expand this out, these are the factors right down here. I've already done this one. So x squared plus 9x plus 2x plus 9 times 2, 18. Now collect like terms, we get x squared plus 11x plus 18. And you can see that is this quadratic up here. So I give you a quadratic in the expanded form, and you give me it in factored form. And they should be the same, but the factored form has some nice advantages. Why would you want to put it in factored form? Well, if this whole thing equals 0, then this factored form also equals 0. And there's something called the zero product property, which says when you have a product of unknowns that equals 0, to solve that you can just look at when each unknown individually equals 0. So what I mean by that is if you look at this left factor, x plus 9, if that is equal to 0, then it doesn't even matter what x plus 2 is, because you'll have 0 times something, which is 0. So to find the solutions to this quadratic equation, I just have to solve the easy equations, x plus 9 equals 0, which gives me x equals negative 9, and then x plus 2 equals 0, which gives me x equals negative 2. So those are the two solutions to the quadratic equation. So in factored form, it's really easy to find the solutions. Another reason factoring a quadratic equation is a good thing to know how to do is perhaps this is the numerator, and you might have something in the denominator that you can cancel once you've factored out this quadratic equation. Maybe you have an x plus 9 in the denominator, and then you can simplify by canceling those. You see that in calculus all the time. So let's figure out how to actually go from the expanded quadratic to the factored form. We're going to do this in a similar fashion to the last video. We're going to start with the factored form and then keep track of the mystery numbers a and b to see what they should look like in the expansion. So I've already expanded this out, with the only complicated step being this ax plus bx. You factor the x out of those and get a plus b all times x. But here is the expanded form of the factored quadratic equation, x plus a times x plus b. You see we have two numbers, a and b, where a plus b is the middle coefficient and a times b is the last term. So in order to factor a quadratic equation, we just need to find a and b such that their sum is the middle coefficient and their product is the final term, and then rewrite as x plus a times x plus b. As something worth mentioning is that this only works when you have a 1x squared. There's a strategy for when you have a say a 2x squared or a coefficient on this x squared, but it complicates the process. So you'll see that at the end of the video. For now, we're just looking at when you have a plain x squared. So again, looking at this x squared plus 11x plus 18, which is the example we started with, to factor this I need to find a and b such that their sum is the middle coefficient and the product is the final term. So let's look at all the products of 18 and then see if any of those add to 11. Factors of 18 gives me 1 and 18, that makes 18. 2 and 9 is 18, or 3 and 6 is 18. So those are all the possible factors. Now I'm going to look at the sum of each one of these. Here we get 19, 2 and 9 makes 11, and 3 and 6 makes 9, but 11 is the one that we're looking for. So 19 is not what we want, 9 is not what we want, but we want it to be the middle term. So this is 11. So 2 and 9 are our a and b, so we can then rewrite this as x plus a times x plus b, or x plus 2 times x plus 9. And so we've taken this expanded quadratic and put it into the factored form. And that's factoring a quadratic equation. Let's do another example. So x squared plus 11x minus 42. So remember, we want to find two numbers that add to 11 and multiply to negative 42. So let's think about factors of negative 42. Now you might have realized that when you have a negative number, it can complicate things, because say I'm looking at the factors 1 and negative 42. Well, another possible pair of factors is negative 1 and positive 42. So am I going to have to look at each one of these? Am I going to have to double basically the number of factors that I need to add up to see if they equal 11? Am I going to have to do that? Well, you would, but you can use some logic to eliminate a lot of those choices. So here's my hint for this one. The positive number has to be bigger than 11. So the positive factor, one of the factors has to be positive, the other has to be negative. Well, the positive one has to be bigger than 11 because you can't increase a positive number with a negative number. So if I have, so this positive 1, this is definitely not a solution because I'm going to be adding a negative number to this, and there's no way I can add a negative number to positive 1 and get 11. So I can cross out all the factors where the positive number is less than 11. So that's going to eliminate some of the factors we have to check here. So we have negative 1 and 42. How about negative 2 and 21? Negative 3 and 14. And then we might have something like negative 6 and positive 7, but you see now the positive number is less than 11, and we need the positive number to be bigger than 11, so we can already eliminate that one. So these three are the only ones that we need to look at. Let's add them up. Negative 1 and 42 is 41. That's wrong. Negative 2 and 21 is 19. That's no good. This is not a variable x. This is not the right one. So negative 3 and 14 gives us 11. That's the one we want because we want it to be the middle term. So these are our factors. So now we can write it in x plus a times x plus b. In this case, x minus 3 times x plus 14. And from there you could solve or do whatever else you want. But that's factoring. So I mentioned a minute ago we would look at what happens when you have a coefficient on the x squared. This actually complicates the process more than you might think. We have to do a few new steps, and I'm not going to prove to you why we have to do these steps because it would take too much time. So I'm just going to tell you what you have to do. So whenever you see a coefficient on the x squared, start off by drawing a box with 4 chambers. So it sounds a little wacko to do that, but it's going to help us figure out what the factors are. So in the upper left, you might say the first chamber or cell of the box, put the first term, so that's 3x squared. In the bottom right, which you might think of as the last box, say if you were reading this as a book, you would read this part last, you put the last term, so that's 8. Now to figure out what you put in the other two cells of the box, multiply the coefficient on the x squared with the last term, so in this case that's 3 times 8 is 24. Now you factor that product and look at which of those factors adds to 10. So 1 and 24, or 2 and 12, 3 and 8, or 4 and 6. For the sake of time, I'm going to skip adding up all these and just show you that 4 and 6 gives us 10. So that's the one we want. But you could add all these up and figure out which ones are not 10 and then find the one that is 10, and that's the one you want. Once you figured out your factors, you're not done like we were before. You have to take those factors and put them with an x in the box like this. Now you have to set up the perimeter of this box so that when you multiply the corresponding row and column number, you get the cell shown. So let me show you what this means. The way you actually figure this out is look along this column and look at the common factor. So the common factor here is a 3x. And then along here, the common factor is just an x. So 3x times x makes 3x squared. So I know that's right. With 4x and 8, the common factor is a 4. And with 4 times something has to be 8, so that's going to be 2. And you can check 3x times 2 makes 6x, so that's good. Now you put plus signs in here and read along this direction, and those are your factors. So our final factored equation is x plus 2, 3x plus 4. Let me do another example before I run out of time, but this is the factored form. So here there's actually an equation, so we have to move everything over to one side. You often want to do that so that you have this equal to 0, because that's often the motivation for factoring. But you can always just subtract everything over to the other side to get one side equal to 0. So remember, we draw our box with 4 cells. First term there, last term here. Now these two we have to multiply 5 times negative 16, that's negative 80. And now we notice that the negative number has to be bigger, or I guess less than negative 16. It has to be more negative than negative 16, because when we add a positive number to it, that'll make it close to 16. So we need the negative number to be more negative than negative 16. So we have 1, negative 80, 2, and negative 40, 4, and negative 20. Again, I'm going to skip adding these up because 4 and negative 20 are the factors we want. 4x is in there, negative 20x is in there. Let's look for common factors. Here's a 5x, that's an x. This is a 4, and this is a negative 4, so our final factors are x minus 4 and 5x plus 4. So that's factoring quadratic equations. Thanks for watching, and I'll see you in the next video.